Previously, we've been using trial and error to solve word problems. We now know through our study of algebra that we can rewrite worded sentences into algebraic expressions, and through our study of equations, we now have the tools to solve an equation to find an unknown value. This means we can solve word problems by rewriting the sentence in front of us as an equation and then solving that equation to find the solution to the problem. There are 4 steps to follow to rewrite any word problem as an equation that can be solved. Firstly, we need to read the question carefully and identify exactly what we're trying to find. This will help us to understand how the value that we find from the equation relates to the question that we've been given. Secondly, we want to change any unknown quantities into pronumerals, which we know from our study of algebra means letters. We're looking just to use one letter for each equation. Step 3, we want to write the problem as an equation using these pronumerals that we've selected. And then the last step is to solve that equation to find the answer for the question given to us. So let's look at an example. As we read through the example, I'm going to highlight all the key pieces of information that will help me solve this problem. So the question reads that we have a rectangle, and that rectangle is twice as long as it is wide. We're also told that the rectangle's perimeter is equal to 20 centimetres, and the question is asking us to find the dimensions, which means the length and the width of that rectangle. Now we can set up all of this important information into an equation that we're able to solve. Looking at the information about the rectangle, we know that the length is equal to twice the width. Now step 2 was to rewrite the question using pronumerals, so let's call the width x. This means that the length will be equal to 2 times x, which we know from our algebra skills is 2x. The last piece of key information is that the perimeter of this rectangle is equal to 20 centimetres. We know that the perimeter is the sum around the outside of the shape, and this will allow us to form an equation that we can now solve to find the dimensions of this rectangle. So, by adding the expressions for the dimensions that we have expressed here, we have 2x plus x plus 2x again plus x again, and this sum is equal to 20, the rectangle's perimeter. By collecting like terms together, I have 2 lots of x plus another 2 lots of x plus x gives me a total of 6x, which is equal to 20. This gives us an equation that is easily solved by dividing both sides by 6, giving us that x is equal to 3 1/3 or 3.3 rounded. Since we said that the width was x, this tells us that the width is approximately equal to 3.3 centimetres. And therefore, since we said the length is twice this, the length must be 6.6 centimetres. And we've solved the problem. Let's have a look at another problem. This problem reads the sum of 3 consecutive even numbers is equal to 72, and we want to find what those numbers are. There's some terminology here that we need to interpret. Firstly, the word sum means to add, and then the second thing that's important is that word consecutive. Consecutive means one after the other. So we're looking for 3 consecutive even numbers. That would be something like 2, 4, 6 or 12, 14, 16. 3 even numbers that follow on from one another. And we need those to add together to give us an answer of 72. So let's pick a pronumeral to represent our numbers. Again, because I like it, I'm going to call it x. So we know that the second number in our sequence would have to be 2 more than that. which would give me x plus 2. And the third number, the final number in our consecutive sequence, would have to be 2 more than that again. So x plus 2 plus another 2 gives us a total of x plus 4. We're told that if we add these numbers together, so the sum of these numbers, has to give us the answer of 72. And by writing it out mathematically, we now have our equation to solve. So by collecting like terms, we have 3 lots of x, and collecting the numerals on the left-hand side gives us positive 6. That equals 72, which gives us a 2-step equation to solve. We start by subtracting 6 from both sides, leaving us with 3x is equal to 66. And then by dividing both sides by 3, we get our first answer that x is equal to 22. Since we said that this was the first number in our sequence, then that means that our sequence of consecutive even numbers must be 22, 24, and 26. And you can check that your solution works by adding them together. When we do that, we do obtain our answer of 72. And so we've solved the problem. Now let's kick it up a notch. The last example involves money. So in my money box, I have $1 and $2 coins. We're told that there are 84 coins in total, and they are worth $139, which means in this example, we're going to have to incorporate the value of our pronumeral and its dollar amount as well. There's 2 things we need to be thinking about here. We're asked to figure out how many $2 coins there are only. So we need to keep that in mind as our solution as well. First, we need to start with a pronumeral. So let's call the $1 coins x. But this isn't really what we're relating to each other. What we're trying to work out is a relationship between the value of the coins and how many I have altogether. The number of $2 coins will be equal to the total number of coins I have in my money box, minus however many $1 coins I have. Now I know I have 84 coins in total, and I've allocated a pronumeral to the $1 coins, calling it x. If the number of $2 coins is equal to the total, which is 84, minus the $1 coins, which is x, the $2 coins would be equal to 84 minus x. Now if we look at the value of these coins, I can see that I have x amount of $1 coins, and if I add that to the number of $2 coins that are in my money box, which is 84 minus x, times their value of $2, we should get the answer of 139. Now while this looks confusing, if I remove the dollar signs, we have obtained an equation that can be solved. So we have 1 lot of x plus 2 lots of 84 minus x, and that is equal to 139. Our equation skills tell us that we must expand the brackets first, so everything inside that set of brackets must be multiplied by 2. So doing that, we have x out the front plus 2 lots of 84 giving us 168 minus 2 lots of x, and that's equal to 139. Collecting our like terms together, we have x, take away 2 lots of x, leaves me with negative 1 lots of x. We have 168, and that's equal to 139. The next step is to subtract 168 from both sides, and while we are going to obtain a negative answer here, we do have a negative x that we need to be mindful of. So that will give me an answer of negative x is equal to negative 29. And by giving the negative to the other side, we obtain the answer x equals 29. Now originally we said that x relates back to the $1 coins. So we now know how many $1 coins exist in my money box, 29 of them. And so the number of $2 coins has to be equal to 84 minus 29, which gives me an answer of 55 $2 coins in total.